So our warm-up for today just says to classify the following variations. We learned 3 types yesterday. There's one of each up here. Which one's the easiest one? Number 3 is what? Joint. Okay, so I'll do that one first. Anyone know the other 2? The first is an inverse, yes. Which makes number 2 direct. Good, one of each. So remember, if you are solved for the constant of variation like in number 1 and they're in a line, it's inverse. If we solved the second one for the 5, the y and the x would be divided, so it's direct. And then if you see 3 variables, it's joint. Questions on the warm-up? Today we are continuing chapter 9. Today is 9.2, graphing rational functions. We're going to continue looking at graphing rational functions tomorrow as well when we start section 9.3. They're a little harder tomorrow. Today is a little easier. I wouldn't say easy, but it's a little easier than tomorrow will be. All right, if you look at your sheet for the rest of the week, 9.3, the harder ones, we're going to spend 2 days on those. Friday is word problem day, and then jumping to next week, we have review quiz. So you will have a quiz a week from tomorrow. Any questions?
What's that? What's review?
Review, like comma, review, comma, quiz. Like Monday's a review, Tuesday's a review, and then Wednesday's a review. Sorry, I talk fast. All right, you need to write all of this down. These are the things you need to know about graphing rational functions that are in this form. The main thing to notice right here is that there are no variables in top. So you have, remember, rational is something that's written as a fraction. So if you have it written as a fraction with the x on the bottom, some number on the top, maybe you're adding something on the end, maybe you're not. These are the things that you need to know about the graph. So go ahead and write those down. We'll talk about them a little more in a second. So you guys know what asymptotes are. We talked about them last chapter. Those are the lines that your graph approaches, but it never touches. Occasionally you'll see vertical, or you'll see horizontal asymptotes that it does cross, and then it approaches as you go to your end behavior areas. But for the ones we're going to look at today, they're not going to cross the asymptote. So we'll have a horizontal asymptote. The horizontal asymptote is usually at y equals 0. But remember, because of our transformations, if you're adding some k value on the end, it can bump it up or bump it down. So if there is no k, you're just going to have an asymptote at y equals 0. All right, the vertical asymptote is going to be whatever makes the bottom 0. We cannot have a value that's undefined. So if it turns the bottom into a 0, that's where we're going to have a vertical asymptote. All right, so if you don't have an h and you don't have a k, your center is just at 0, 0. And then these are, again, related to transformation. So if you're adding some value on the end, that's going to move your center up or down. If you're adding or subtracting something to the x, that's going to move your center left or right. Okay? So once you find out where your center is, your asymptotes go through the center, and then you pick a point on each side, make an xy chart, and go from there. Any questions? These kind of take a while. Again, if you have a graphing calculator, that would be very helpful. If you don't, I would check all your work using one of those internet sites we talked about, like Desmos or Wolfram Alpha, because these graphs are a little bit more complex than we're used to. Any questions before we look at our examples? All right, here's the first one. Yeah, if you want to use a graphing paper, that's fine. If you want to just sketch it in your notes, that's fine too. Whatever you're comfortable with. So we first want to decide where our center is. That's going to tell us where our asymptotes are. So the y value is whatever they're adding or subtracting on the end. Is there anything being adding or subtracted on the end? Okay? And then the x value is the opposite of whatever's going on around the x. Is anything going on around the x? No. So our center is going to be at 0, 0. Now, they put a dot here just to show you, or I put a dot there just to show you where it is. This is not actually a point on the graph. Okay? There is no real point there. I'm just showing you where the graph is going to be centered around, but that's not part of the graph. So if you want to leave that part out, that's fine. All right, the asymptotes are going through that center. So we are going to have a vertical asymptote at the line x equals 0. So asymptotes we usually draw in as dotted lines. So I'm going to put a dotted line there. My graph is not going to cross this dotted line. I need a horizontal asymptote as well through the center. Horizontal lines are y equals, so it's going to be at y equals 0. So you can see there's another asymptote. So the axis are both asymptotes in this particular graph. Because we're not adding or subtracting anything on the end. So if we were adding like 1 on the end, then we would have an asymptote at 1. Or if we were subtracting 2, we'd have an asymptote down here at 2. All right, any questions so far on my asymptotes? Remember, those are the lines we can't cross. We had those in exponential functions and in the log functions we did. We didn't concentrate on them too much. We kind of just related back to them during the domain and range. But we're going to do a lot more with them this chapter. All right, once you know that, pick 2 points on the right side of your vertical asymptote and on the left side of your vertical asymptote. So 2 points to the left of 0, 2 points to the right of 0. Plug them in for x, see what you get for y. So negative 2 divided by negative 2, of course, is 1. Negative 2 divided by negative 1 is positive 2. So those are your 2 points to the left. 2 points to the right. When I divide negative 2 by 1, I get negative 2. Negative 2 divided by 2 is negative 1. And then you're going to connect those. You're never crossing those asymptotes. So your 2 points to the left are their own curve. 2 points to the right are their own curve. You can see as you're getting closer to 0 from the left, it's approaching this asymptote. Closer to negative infinity, it's approaching your other asymptote. And then same story over here. When you're getting closer to 0, it's going down, but never crossing that asymptote. And approaching infinity, it's getting closer to your vertical asymptote, also without touching it. Now, you can check these using a graphing calculator, like I said, like a website, like I said. The only thing they will not show you is where your asymptotes are. Technology does not put in these dotted lines. Remember, those are just kind of to help you, to guide you in graphing. So you won't see those. Remember, this isn't really a point. It just kind of helps me set those asymptotes up. But it will give you these curves. What are your questions on this? All right, we still have one more thing. We're going to talk about the domain and the range. There is only one value left out of the domain. What is it? 0. All real numbers except x equals 0, because we have an asymptote there. Or because it will make your function undefined. So that's not good. Where is your vertical, what's your range? There's also one value that's not going to work in your range. 0, same thing, yes. It's where your other asymptote is. So we will not have y values of 0, because if you plug 0 in for here and try to solve for x, it's not possible. So you cannot have x values of 0, you can't have y values of 0. All other numbers are just fine. So you can see how these are getting a little more complex than we're used to, right? They take some time. Any questions? All right, here is number 2. So we're going to start by finding our center. So you look around the x to find the x value of your center. Anything going on around here? No. So that's going to be 0. What's the y value going to be? 5 because you're adding 5 on the end, so it's going to bump everything up 5. So our center is at 0, 5. Now, a dot appears at 0, 5. A point, that's not actually a point on your graph, remember. That's just kind of guiding our asymptotes. So if you want to skip that point, that's fine. If you want to draw it in, that's fine. But your curve will have nothing to do with that point. It won't go through it or anything. All right, so we have a vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 5. So that center just helps us set up those asymptotes. And you can see the x value of your center is your x equals asymptote. The y value of your center is your y equals asymptote. Our graph is not going to cross either one of those. Now, 2 values to the left of your vertical asymptote, 2 values to the right of your vertical asymptote. So we can do these. Now, you might say, well, I wanted to do -2. That's fine. If you do -2, you're going to have a fraction. If you make it a -3, you won't. So if you want to work with fractions, that's fine. If you want to be a little more strategic and make sure that you only get whole numbers, that's fine too.
Well, I thought you said it has to be 2.
2 points to the left and 2 points to the right. So in the last one, we used -2 and +2. And we could avoid fractions that way. If you put a -2 in here, that's fine. You would just get -1/2 plus 5. So if you want to do that, that's fine. You'll get the same graph. But I just want to avoid fractions altogether. So I saw if I plug a 3 and a -3 in, it'll avoid the fractions. So it's up to you. As long as you pick 2 points to the left and 2 points to the right. It doesn't matter what this. Doesn't matter. I just picked the easier ones. So if I put -3 in there, I get -1 plus 5, which is 4. If you plug -1 in there, you get -3 plus 5, which is 2. When you plug 1 in, you get 3 plus 5, which is 8. And when you plug 3 in, you get 6. Now I'm going to connect those, never crossing those asymptotes. So again, it's kind of like 2 separate graphs. This one and this one, they're approaching those asymptotes, but they're never crossing them. Questions so far? My domain's going to be all real numbers except which one? 0. Remember, domain has to do with your x's. The range is going to be all real numbers except 5. The range has to do with your y's. Good. What are your questions? I cannot stress enough how helpful technology will be with this. Use it. Questions? All right, here is number 3. All right, what's this -3 next to the x doing to our graph? Moving it left or right? Right, so that's going to give us a center with an x value of 3. And then, of course, the 1 is just going to bump it up 1. So our center here is at 3, 1. Again, there is a point that appeared at 3, 1 that is not actually part of our graph. It's just going to help us set up those asymptotes. So we are going to have an asymptote at basically the 2 places you see in the center. X equals 3, y equals 1. X equals lines are up and down, so that's our vertical asymptote. Y equals lines are horizontal, side to side. That's our horizontal asymptote. Any questions so far?
If you have the 3, the center and the vertical, why would you divide by 6? Or like...
The vertical asymptote has to do with what makes the denominator equal to 0.
Okay.
So how would you get this to equal 0? You'd add 3. 0 plus 3 is 3. Well, the center is just the point where each of the asymptotes goes through. So if you've determined that you need a vertical asymptote at 3, that's where your center is going to be. All right, 2 points to the left of 3, 2 points to the right of 3. Doesn't really matter. You can pick. I just picked the 2 to the left, 2 to the right. And then start plugging them in. When you plug 1 in, you would get 2 divided by -2, which is -1, plus 1 is 0. If you plug 2 in, you get 2 divided by -1, which is -2, plus 1, which is -1. When you plug a 4 in, you'd get 2 divided by 1, which is 2, plus 1, which is 3. And when you plug a 5 in, you would get a 2 in the bottom. 2 divided by 2 is 1. 1 plus 1 is 2. Connect them. Don't touch your asymptotes. And you're done. Questions on this? I do have one piece of advice. I keep telling you to check these using graphing calculators or technology. If you are typing this into a graphing calculator, make sure that you put parentheses around that so it doesn't kick that -3 out from under the fraction. Make sure that it knows that that whole quantity is in the denominator. Any questions? All right. Domain. All the x values besides 3. The range is going to be all the y values except 1, again, because those are our asymptotes. So once you figure out the asymptotes, the rest of it's just kind of the same process. Questions? Of course. So the first thing you want to do is figure out where those asymptotes are. Yeah, -5, -2. So we've been calling that our center, even though that's not really a point on the graph. But it does help us find our vertical asymptote, which is through x equals -5, and our horizontal asymptote, y equals -2. And again, remember, the x part is always the opposite because adding 5 to the x value moves your graph left 5, so that's why this is -5. Subtracting 2 on the end moves it down 2, so that's why this is down here. All right, now just pick 2 points to the left of your vertical asymptote, 2 points to the right of your vertical asymptote. It doesn't really matter how far you go here. I just went 2 in each direction. All right, the rest of this is just some calculation. You will end up with some fractions here. I'll let you guys check those if you want. And there we have it. So again, once you get to this point, it's just kind of following the same old steps to find the rest. The domain, what can we not have as an x value? -5. It's always wherever the asymptote was. What can we not have as a y value? -2. Good. Remember, we can't cross those asymptotes. What are your questions? Yes, ma'am. So we're still talking about rational functions. They're just in a little bit different form now. The tip-off that you're in this form is you have x's in the top and the bottom. So previously we just had x's in the bottom. So we were following all those steps from the first slide we looked at. Now it's a little different. You have x's in the top and the bottom. So go ahead and write these down and then we'll talk about what they all mean. This really changes things a lot. So when you're in this form, again, like I keep saying, once you find those asymptotes, it's really the same process. So the only difference now is how we're going to find those asymptotes. So the vertical asymptote, it's pretty much the same process, it just takes an extra step. The vertical asymptote is going to be whatever makes the bottom equal to 0. So if you set Cx plus D equal to 0, you'd subtract D from both sides, and then you would divide by C. So if you want to use the shortcut of negative D over C, that's fine, or you can just solve by setting it equal to 0 each time. Any questions on the vertical asymptote? The horizontal asymptote is a little bit different. When you have the same number of x's in the top and bottom, your horizontal asymptote is always this ratio. So if they're both x squareds, or if they're both x's to the third, x to the fourth, it's always whatever this ratio is, the lead coefficient ratio. So if it's just an x over an x, it's just whatever coefficient was with the top x divided by whatever coefficient was with the bottom x. Once you find those asymptotes, 2 points to the left, 2 points to the right, and you're done. Any questions? Just a little trickier, a little more to think about than the last time. All right. Here is number 7. So let's look at our vertical asymptote first. The vertical asymptote is whatever's going to turn the bottom into a 0. Negative 2. It's a vertical line, so it's an x equals negative 2. If you want to write out the center part like we did last time, you can. I'm just jumping right into those asymptotes, though, just because they're a little harder to find now. All right, we have the same number of x's in the top and the bottom. Do you all agree with that? So our horizontal asymptote is just going to be the ratio of the lead coefficients. 1 over 1, which is 1. So our horizontal asymptote is the line y equals 1. That's the hardest part. Once you have those two lines in there, you are good to go. We need 2 points to the left and 2 points to the right. Now just be careful because you're plugging x into 2 places, so it might just take you a little longer to calculate. This is going to be negative 4 over negative 2, which will give us positive 2. This will be negative 3 over negative 1, which will be positive 3. Then you will get negative 1 over positive 1, which is going to be negative 1. Then you'll get 0 over whatever, it's going to be 0. And then you can fill in your lines. So again, not a completely different process, just finding those asymptotes they get a little more complex. Questions on number 7. So remember, domain and range it's basically the same as where your asymptotes are. That's where your domain cannot be and your range cannot be. Questions on the domain and range part? All right. Here's the next one. We will start with vertical asymptote first. Vertical asymptote is whatever's going to make the bottom equal to 0. X equals 4. Good. Now, you can see my graph is counting by 2s. If you want to do yours counting by 2s, that's fine. You guys can put a little more detail into yours because they don't have to be so zoomed in like mine do. So you can count by 1s if you want, that's fine. Where is the horizontal asymptote? Remember, if you have the same x's in the top and the bottom, same degree, meaning same exponents, it's just the ratio of the lead coefficients. So this is like 2 over 1. So y equals 2. Again, in the y direction, I am also counting by 2's here. Now you just pick 2 points to the right, 2 points to the left. And again, that is all related to that vertical asymptote. I just don't want to plug a 4 in. I want to plug 2 points to the left of 4, 2 points to the right of 4. When you're plugging them in, you're plugging them in for this x and this x. So 2 times 2 in the top, 2 minus 4 in the bottom. That's going to give you a negative 2 when you simplify. When you plug a 3 in, you would get 6 over negative 1, which is negative 6. When you plug 5 in, you would get 10 over 1, which is 10. And when you plug 6 in, you'll get 12 over negative 2. Oh no, 12 over positive 2, excuse me, which is positive 6. Any questions on those points? All right, go ahead and connect them, and you are good to go. Questions? All right, we've got 2 more to look at. Oh, I always forget the domain and range. What can the domain not be? 4. What can the range not be? 2. So it's all real numbers besides x equals 4, all real numbers besides y equals 2. All right, now we have 2 more examples. So here is number 9. Let's look at our asymptotes first. Where's that vertical asymptote going to be? X equals negative 3. Good. Again, the reason is it's because that makes the bottom of our fraction equal to 0. Where's the horizontal asymptote? 1. It's the ratio of the lead coefficients. So 1 over 1 is 1. So y equals 1. Keep saying this, but once you have those, it's a piece of cake. 2 points to the left, 2 points to the right. Plug them in and graph them. So my 2 points to the left of negative 3, I went with negative 5, negative 4. 2 points to the right of negative 3, I went with negative 2, negative 1. And then it's basically just plugging in and simplifying. So this would give you a negative 3 over negative 2, which is just 3 over 2. 3 halves. When you plug negative 4 in, you get negative 2 over negative 1, which is just 2. When you plug negative 2 in, you get a 0 on top, so I don't even care what you get on the bottom. And when you plug a negative 1 in, you're going to get 1/2. Your domain will be all real numbers except negative 3. Your range will be all real numbers except one. Good. All right, I'll give you guys some time to catch up. And then we'll do our last example. All right, here's our last example for today. First thing I want to look at is the vertical asymptote. Remember, that's whatever makes your denominator equal to 0, which will be what would make this equal to 0? 3 over 2. Good. So x equals 3 halves. So again, that's kind of between the 1 and the 2. Horizontal asymptote is the ratio of those lead coefficients, which is half. Yep. So y equals a half. So that looks like it's going to make things super complicated. But remember, you get to pick the points to the left and the right. So you don't have to keep plugging in fractions if you don't want to. From here, 2 points to the left, well, 1 is to the left, and so is 0. Those are super easy to plug in. And 2 and 3 are also to the right, and they're whole numbers, and they're easier to plug in. So don't see fractions and think you have to make the whole problem related to fractions. Go ahead and start plugging in some whole numbers, as long as you have 2 to the left and 2 to the right. Alright, when you plug 0 in, you're going to get a third because you would get -1 over -3. When you plug 1 in, you get 0. Since you get a 0 on the top, we don't even care what you get in the bottom. When you plug a 2 in, you get 1 because you get a 1 in the top, a 1 in the bottom. When you plug 3 in, you get 2/3 because you get a 2 in the top, and a 3 in the bottom. And then just connect them. So you're very close to the asymptotes in all directions here. Just make sure you don't cross them. Alright, domain and range, same old thing. Domain is all real numbers except where you have that asymptote. And the range is all real numbers also except where your asymptote is. So you guys can see these graphs are pretty tricky, but once you get the process down, it's really just the same process over and over. Questions on this? Alright, here's your homework. It is only the odds. Like I said, we are going to continue graphing tomorrow, but it will be in a new section, so don't hold off on this homework. However, tomorrow's homework you will have 2 days to work on. Let me know if you need anything.